The second parent function is f of x equals x. It's referred to as the identity function. We could write y equals x up here at the top. The reason we call it the identity function, kind of like the number 1 is the multiplicative identity, because if you multiply any number like 8 times 1, you just get what you started with. If I put anything for x, I'd get that number for y. It doesn't change anything. So the point -2 is on the graph. Let me go put -2 on the graph. The point 0, 0 is on the graph. The point 10, 10 is on the graph. The point -10, 10 is on the graph. The graph of y equals x is a line where all of the coordinates are the exact same. Goes through the origin, has a slope of 1. You're pretty familiar with that. What are the intercepts? X equals 0, y equals 0. What is the domain? I can put anything I want in for x, and so it's -infinity to +infinity. What is the range? I can get anything for y, so the range is -infinity to +infinity. Is it odd or even? Well, it's not symmetric with respect to the y-axis, but it is symmetric with respect to the origin. Pick any point, go across the origin, there will be a buddy point. So this function is odd because it is symmetric with respect to the origin. I mean, I'm going to abbreviate it, but I'm going to put it in there. Give me an x interval over which this graph is increasing. Well, it's always going up. If the graph's going up, it's increasing. So I'm going to say -infinity to +infinity. Over the entire course of the domain, that graph is always increasing. So where is it decreasing? Nowhere. I'll put an empty set. Where is it constant? Nowhere. Put an empty set. Where is it positive? Well, these are negative y values, and these are positive y values. And since these questions are all about the y behavior, we answer it with x's. So from 0 with parentheses up to +infinity, and by that I mean over this x-axis right here, all of the y values are positive. Absolute maximum or minimum? No, it just keeps on going. So nothing there and nothing there. There's your parent function y equals x. The next one, everybody's favorite, f of x equals x squared. It's the parabola. So here, I'll just put a little marks around those. You should always put in points to see what you have. You put in a 0 and square it, you get 0. You put in a 1 and square it, you get 1. You put in a 2 and square it, you get 4. You put a 3 in and square it, you get 9. There's what my points look like. Now on the other side, when I put -1, I get +1. -2 gets me 4. And -3 gets me 9. Hey, look, I've got points on the other side of the y-axis. This is an even function, isn't it? All right, so there's my graph of my parabola. Put in enough points to make sure I graphed it appropriately. It should be a U shape at the bottom. You should not connect that with a V. I'll be so mad if you make that a V. The intercepts, the x equals 0 is an intercept and y equals 0 is an intercept. They happen at the same time at the origin, just like happened up here. The domain, I can put anything I want. Look at that equation. There is no limit on what you could put in for x. It's -infinity to +infinity. What's the range? The range are the y values that get used. Since x squared turns everything positive, I can't possibly get anything negative. So the range is not all real numbers because I'm missing all the negatives. You can get 0 and anything bigger. So the range is 0, +infinity, just like that. Except I shouldn't have parentheses. I should have a bracket because you can put in 0 and get 0. So bracket your range up, people. Is it odd or even? Well, we already decided it's symmetric with respect to the y-axis. That makes it an even function because it's symmetric with respect to the y-axis. Okay. Where is it now? Remember, the other way of telling if something was odd or even is if you find f of -x and you find f of x. If they're the exact same, it's even. If they're the exact opposite, it's odd. So let me just run that through one time here for this even function. This would be -x raised to the second power, and this is just as it was. Aren't those the same? If I square this, doesn't it become +x squared? So since they're the same, the graph is even. Okay, where's it increasing? It starts increasing here at 0, and it goes increasing forever. So that's going to be parentheses 0, +infinity. The parentheses, not the bracket, because at 0, it's not increasing. It's plateaued. Decreasing. Well, it's decreasing here. As you go left to right, it's decreasing until it hits that minimum, and then it's increasing. So from negative infinity up to 0, that graph is decreasing. Where is it constant? Nowhere. It's always curving somewhere. Where is it positive? Everywhere but 0. So this isn't great, but we're going to have to write it like this. Negative infinity up to 0 with parentheses, meaning we don't include 0. And then the union of 0 comma positive infinity. There's another way to write that, and it goes like this. Wherever x isn't 0. But if you're asked to put in interval notation, that's what we get. Is there an absolute max or min? Yes, there is. Y equals 0 from the point 0, 0 is an absolute minimum. Local max and min, I'm going to say no, because that's an absolute maximum. Local max would be something like this guy right here. That is a minimum for everybody in its area, but it's not local. It's not absolute because there's one that goes even lower. Let's go to the next page.